They were the first spacecraft to leave the solar system, the fastest ever created by humankind, and they are still sending back photographs from the outer reaches of the solar system. These are just some of the myths many people believe about the Voyager spacecraft. But would you believe that none of these claims are true? In this video, we'll show you the 7 most popular myths people believe about the Voyager space probes and the truth about them. Let's begin. The Voyagers were designed with the sole purpose of leaving the solar system. This statement sounds epic, but it's not entirely true. When the Voyager 1 and Voyager 2 probes were launched in 1977, their primary mission wasn't to travel to interstellar space, but to explore the outer planets of the solar system. In fact, their design and programming were geared toward taking advantage of a rare planetary alignment that occurs only once every 176 years, allowing them to visit multiple planets with a single launch thanks to each planet's gravitational pull. Voyager 1's primary objective was to study Jupiter and Saturn. Voyager 2, on the other hand, was programmed for a longer journey, visiting not only Jupiter and Saturn, but also Uranus and Neptune. Neither of them had leaving the solar system as their original primary mission. Furthermore, the term interstellar mission wasn't part of NASA's official vocabulary until years later, when both probes had already surpassed their initial objectives. That doesn't mean NASA engineers didn't consider the possibility. The Voyagers were equipped with long-lasting power sources, robust technology, and solar escape trajectories, enabling them to continue their journey indefinitely. But in the 1970s, talking about leaving the solar system was more of a remote possibility than a concrete goal. The interstellar phase of the mission officially began in 1990, only after the probes had completed their planetary flybys. It was then that their new role as the first human messengers to deep space was recognized. So, no, they weren't built solely to leave the solar system. What took them so far wasn't a predetermined mission, but their remarkable durability, their favorable trajectory, and the subsequent decision to make the most of a unique opportunity. They were the first probes to leave the outer limits of the solar system. This is one of the most common misconceptions, and it makes sense that people believe it. After all, the Voyager probes are the most famous, have traveled the farthest, and continue to send back data from the outer reaches of the solar system. But no, they were not the first to cross the boundary of the outer solar system. Before the Voyagers, NASA had already launched the Pioneer 10 and Pioneer 11 probes. Pioneer 10 was launched in 1972 and became the first spacecraft to cross the asteroid belt and fly by Jupiter in 1973. Pioneer 11, launched in 1973, not only visited Jupiter, but also became the first probe to reach Saturn in 1979, 4 months before Voyager 1. Both Pioneers were the first to cross the orbit of Neptune, the outermost planet in the solar system, though neither visited it. In fact, Pioneer 10 was the first human-built spacecraft launched on an escape trajectory from the solar system, a feat often mistakenly attributed to the Voyagers. So why did the Voyagers get all the fame? Because their missions were much more ambitious and detailed. Their camera and sensor systems were more advanced, and their planetary flybys provided images and data of unprecedented quality. Furthermore, they were the first to visit Uranus and Neptune in the case of Voyager 2, and the first to cross the heliopause. At this boundary, the influence of the solar wind ends and interstellar space begins. The Voyagers weren't the first to leave the planetary neighborhood, but they were the ones that explored it the most thoroughly and continued to transmit information decades later. This demonstrates that sometimes history doesn't remember the first to achieve something, but rather the ones who did it best. Of course, this doesn't diminish the merit of the Pioneer probes, which planted the seeds for the discoveries that the Voyagers would make. Hey Curious Squad, before moving on, be sure to subscribe to our channel, clicking on the notification bell, and leave us a thumbs up so you don't miss out on our daily videos. Both probes still function perfectly and transmit real-time images of deep space. This statement sounds spectacular, but it's far from the truth. Today, both Voyager 1 and Voyager 2 are still active, yes, but to say they function perfectly is to ignore 45 years of wear and tear and technical failures. And the claim that they transmit real-time images is entirely false. The cameras were turned off more than 30 years ago. In 1990, when Voyager 1 finished its flyby of Saturn, it entered its interstellar phase, so it would no longer encounter anything to photograph. To save energy, the engineers decided to permanently turn off the cameras. But before that, Carl Sagan proposed giving the probe the command to look back and capture a last look at Earth. This is how the famous pale blue dot image was born, showing Earth as seen from 3.7 billion miles away. Since then, neither spacecraft has taken or transmitted a single additional image. As for communications, nothing happens in real time. The Voyager radio signals travel at the speed of light, yes, but at such immense distances, more than 15 billion miles for Voyager 1, a signal takes more than 22 hours to reach Earth. So, no, the Voyagers don't work perfectly. They don't transmit images, and they don't do so in real time, even though their resilience and longevity make them two of the most outstanding achievements of space exploration and human engineering. They have already completely left the solar system. It is often said that the Voyager probes have already left the solar system, and while this statement has some truth, it is also misleading. In reality, what they have done is cross the heliopause, the boundary where the solar wind ceases to have an influence. But that does not mean they have completely left the solar system. To understand this, we need to define clearly what leaving the solar system means. If we are referring to the area dominated by the Sun in terms of solar wind and magnetic fields, then yes, Voyager 1 crossed the heliopause in 2012, and Voyager 2 did so in 2018, becoming the first human-made objects to enter interstellar space. This region is beyond the heliosphere, a kind of bubble of solar particles that surrounds all the planets. But if we consider the solar system as the entire territory under the Sun's gravitational influence, they are still a long way from leaving, since this region includes the Oort cloud, a gigantic sphere of comets and planet-forming debris that surrounds the solar system and extends to almost 100,000 astronomical units from the Sun, or more than 9.3 trillion miles. To put this in perspective, Voyager 1 is currently about 15 billion miles from Earth, which is barely 0.1% of the way to the edge of the Oort cloud. At that speed, it would take at least 30,000 years to completely leave what we might call the extended solar system. So yes, the Voyagers have left the influence of the solar wind, but they are still very, very far from leaving the solar system altogether. What they have crossed is the threshold of the heliopause, not the absolute edge of the solar realm. They are the fastest spacecraft ever created by humankind. It's common to hear that the Voyager probes, being so far away, must be the fastest ever built by humans, but this isn't true. Although both reached impressive speeds for their time, today's spacecraft have far surpassed them. Voyager 1, the faster of the two, travels at about 38,000 miles per hour, approximately 61,000 kilometers per hour relative to the Sun. That makes it the most distant human-made object from Earth, but not the fastest. Voyager 2 travels slightly slower at about 35,000 miles per hour. These figures are astonishing, but they have been surpassed. The fastest spacecraft ever built to date is the Parker Solar Probe, launched by NASA in 2018 to study the Sun from a record distance. Thanks to multiple gravity assists from Venus and its increasingly close orbit around the Sun, Parker Solar Probe will reach an estimated top speed of 430,000 miles per hour, or about 700,000 kilometers per hour. This speed is more than 11 times greater than that of Voyager 1. Of course, there's a key difference. The Voyagers are traveling into interstellar space away from the Sun, while Parker is falling towards the Sun, which accelerates it as it approaches. There are also other spacecraft that have reached higher speeds, such as New Horizons, which flew past Pluto, and Helios 2, a German solar probe from the 1970s, which reached 150,000 miles per hour when it approached the Sun. So no, the Voyagers aren't the fastest, although they are the farthest away. Their legacy lies in their endurance, escape trajectory, and longevity, not in their record-breaking speed. The Voyagers use solar panels to supply power. At first glance, this statement seems logical. Today, almost all space probes and satellites use solar panels to generate power, from satellites in Earth orbit to missions to Mars and Jupiter. But for the Voyagers, this would be a recipe for total failure. Why? The reason is simple. Solar energy is useless in deep space. As a spacecraft moves farther from the sun, the intensity of sunlight decreases drastically. At the distance at which the Voyagers operate, currently beyond 15 billion miles, sunlight is so weak that not even the largest solar panel in the world would generate enough energy to power a digital clock. That's why the Voyagers use a completely different technology: radioisotope thermoelectric generators, or RTGs, a nuclear power source. Each Voyager is equipped with 3 RTGs, devices that convert the heat generated by the natural decay of plutonium-238 into electricity. These generators have no moving parts, are incredibly reliable, and were designed to operate for decades, though not forever. Over time, plutonium decays and its heat diminishes, meaning the Voyagers generate progressively less power. Currently, they produce less than a third of the electricity they generated at launch, forcing them to shut down scientific instruments one by one to conserve energy. In other words, the Voyagers are nuclear-powered, not solar-powered. Their mission would never have been possible with solar panels, and thanks to their RTGs, they have continued operating in one of the most hostile and isolated environments in the universe. They can still send full scientific data for many more decades. The idea that the Voyagers will continue sending data for decades sounds epic, but it's not realistic. Both probes are nearing the end of their operational life, and NASA has confirmed that only a few years of viable scientific operations remain. The core problem is power. As we mentioned in the previous point, the Voyager's nuclear RTG thermoelectric generators are producing less and less power, so there will come a time when they simply won't produce enough energy to keep the probes running. Added to this is physical wear and tear. With more than 45 years of operation, several systems have failed or lost accuracy. In 2023, Voyager 2 temporarily lost contact due to an orientation failure. In 2024, Voyager 1 stopped sending readable scientific data due to a failure in its storage system. Furthermore, the transmission speed is very low, barely 160 bits per second, and the signals take more than 22 hours to reach Earth. With such limited capacity, the quality and quantity of scientific data they can collect are significantly reduced. NASA estimates that between now and next year, 2026, the last active scientific instruments will stop working and be shut down. When that happens, we will no longer be able to contact them and the mission will be declared over. But the Voyagers will continue traveling alone, silently, traversing the void of space for eons until, with some luck, an extraterrestrial race finds them and discovers that, in some corner of the universe at some point, there existed a civilization of advanced apes that managed to send a message to the universe. You're not alone. We are here. Can you imagine this actually happening at some point in the future? What would happen if a civilization from a star near the Sun, like Alpha Centauri, were to find one of the Voyager probes? If you'd like to explore this possibility, watch this video.